uncertainty principle in the way that it perhaps ought to be looked at, rather than the way in which it is traditionally viewed. Now, the traditional viewpoint of the uncertainty principle, which was proposed by Heisenberg many, many years ago, is that you cannot measure the speed and the trajectory of something at the same time that you're measuring its position. This is quite a famous principle, and it underpins a lot of quantum mechanical equations, but it also lends itself logically to other aspects of nature and existence that classical physics or classical quantum mechanics there is no such thing as classical quantum mechanics. There's classical physics and there's quantum mechanics, and never the twain shall meet, apparently. Uncertainty itself appears to be a feature of nature. Here on the chart, I've drawn 6 versions of you, or me, or somebody else, whoever. Let's just say it's you. And these 6 versions of you are going to be doing slightly different things at any given moment. The wave that collapses into your particle reality could have collapsed in any number of ways, but it happened to collapse into this particular one at this present moment in time. The other versions of you, well, let's have a little think about where they might have gone, because that kind of depends a little bit on the multiverse, or Everett's interpretation. This is a diagram representing the multiverse. The multiverse is seen as neatly stacked brains, B-R-A-N-E-S, of what is known as the bulk, the potentially infinite array of universes potentially out there. These neat stacks don't fit with my view of nature, because it seems, does it not, that nature doesn't like straight lines. Nature is more in favour of asymmetry. Nature favours uniqueness. Now, this is a plot of the traversal of a human being. Let's say it's your plot. And these little lines represent the decisions that you make and things that you do with your life between this point here, let's call that now, and this point here, which is sometime in the future. All these little dots could be any other number of permutations. So instead of that line that you took going in that direction, you might have taken a different route and come down here. You could have gone anywhere on this higgledy-piggledy map, which is essentially my representation of how the multiverse works. All these neatly stacked brains are actually, in my opinion, together. They are somehow intersected. If this is the case, then we do not know at any given point in time which brain we're occupying. Because any brain that we occupy could still be full of the same people, the same birds and animals, the same objects, but be aligned with, adjacent to, the brain that we stepped out of, and we wouldn't know. I could walk out of this room and walk into another version of the multiverse without ever knowing that that's what I've done. It's just a sliding doors effect. The option that you took to take this line, which could so easily have been an option to take a different line, has taken you into a version of the multiverse that will lead to point B. Now, coming back to this diagram, All these versions of you, therefore, are occupying a slightly different space-time. They are all occupying a different brain of the multiverse, but they are all interchangeable. You can become that version of you, just like that, if the quantum mechanical principle that applies to quarks and neutrinos is anything to go by. The quark and the neutrino both change from one thing to another, and the thing that they change from and to can be very, very different in mass and energy. Hugely different. I have an example written on this scruffy piece of paper here. The up quark is 2 MeV, the down quark is 4.8 MeV. But the down quark is twice as heavy, has twice as much mass energy quotient as the up quark. The strange and charmed quarks, which are also paired, you have 92 MeV for the strange and 1270 MeV for the charm quark. So there again is a huge difference in energy mass ratio. Let's go to beauty and truth. Remember that these quarks are all interchangeable with each other. There is no reason why an up quark shouldn't become a strange quark, and a charm quark shouldn't become a beauty quark or a truth quark or whatever. So they are all interchangeable. Now the beauty quark, also known rather disparagingly as the bottom quark, weighs in at 4.19 GeV. That's giga electron volts. That's massive, huge. The truth quark, also known equally disparagingly in my opinion as the top quark, weighs in at 172 GeV, giga electron volts, or gargantuan electron volts as I used to call them. So there is the difference between the weights of quarks. These are the things that we're made of. We are made of these particles. So given that that is the case, it's also the case for neutrinos. Neutrinos oscillate as they fly. They change from one flavour, as it's known, to another as they travel. And there are equally huge disparities between mass energy quotient of, say, the electron neutrino to the tau neutrino, which is huge, gargantuan again. So for tau, read truth. Maybe there's a correlation in there. We don't know. I might take that out on the edit. So here you are, all 6 of you, all these versions of you, just as there are 6 versions of quarks. And potentially all these versions of you are oscillating from one to another, which corresponds to the phases that we encounter. Now we may find ourselves in a phase of life for a very, very long time before something happens and suddenly, bang, and we're on a completely different trajectory altogether. Now, that can happen to anybody at any time. Everybody is unique. We know that every grain of sand and every snowflake is unique. There are no two the same. According to the evidence that's before us, every snowflake, every grain of sand, different from every other in some small way. Now they originate from the same process. Snow is created in the sky, water freezes in the upper atmosphere, and then it falls. Sand, similarly, is produced by the friction of the ocean grinding down rocks and shells and various materials to create this fine tilth that we call sand. The process is the same. The uniqueness is, however, embedded in the product of the process. And that's where it gets interesting, because that's where you can see the signal of a force. at work, a force of nature. There has to be a force of nature that governs uniqueness. These colours, these colour patches, they represent the options, the possibilities that you could branch into any time you make a decision in your world. There is a theory, I don't buy it, but there is a theory that every time a decision is made by a particle to go one way or the other, another universe is created to accommodate the choice. Now, I think that's a lot of BS personally, but there is some merit to the concept that each choice finds itself in a different universal framework. There is always some difference between one event and another, between your walking the dog and a future event of walking the dog. No two walks with the dog, even if you take the same route, will be exactly the same. The dog will sniff in different places, your footsteps will be in different places, the clouds will be different. There is no cloud structure in the sky that is the same, exactly identically the same as any other cloud structure in the sky. This is how deep uncertainty goes. This is how deep uniqueness is embedded in the format of nature. Professor Brian Cox is a physicist in England who was a rock star for a while and then became a presenter. He said in his book, which I can't even remember the name of now, and I'm not going to sell it by quoting its title anyway, but he said, "The uncertainty principle is a doorway through which all kinds of charlatans and purveyors of tripe may force their philosophical musings." Now, I was really cross when I read this, because it seemed to me that he was being very dog in the manger about physics and saying, you can't come in here if you've got any different ideas to mine. And a lot of physicists are like this. You can't go into the echelons of quantum mechanics unless you can understand the equations and know all about the maths, etc., etc. There are all sorts of caveats that you have to fulfill before you can be qualified to investigate quantum mechanics. Well, that's a load of rubbish. You can be whoever you want to be and interested with good reason in quantum mechanics, because it affects your life. It affects directly the way you view your life, the way you live your life, and what you can potentially do with it. This is just one example of a very important principle. There are many others. Well, in fact, there aren't that many others, actually. It's really relatively simple. There isn't a great deal to grasp of the fundamentals of what is happening in the quantum world. My videos hopefully will help you to be able to open an understanding of quantum mechanics and what it means to you, how it relates to the world in which we live, and hopefully will also set you off on an exploratory process of your own. So, cherry pick, pull out the wheat from the chaff. Don't worry about the equations, just look at the words, the descriptions. There's plenty to discover and plenty to explore. So what I would like to leave you with today is simply the thought that anything that you choose to do, you can choose to do it with the certainty that it hasn't been done before. Nobody has done it before you in exactly the same way. So take care, have fun, love you loads, and I hope to see you again very soon. Cheerio, bye.